Bismillahirrahmanirrahim. We'll continue doing these problems. That was the last one we did. I finished the idea of 9.1. Now I'm doing problems. Okay. Now this one is the other way. Usually he gave me the function and he wants the series. Now he gave me the series and he wants the function back. Okay. Yeah. If you think about this one is what? N equal 1 to infinity minus 1 to the power n plus 1, 1 over 3 to the power n over n. Okay. So it's actually x to the power n over n. Okay. Yeah. So when it comes to my mind, x to the power n over n. Usually I have summation x to the power n. So to have n in the denominator, I need to do what? Integral. Yeah. So what shall come to my mind? The ln. The ln will come to my mind. Because the integral, I have integral of something x something. So I have the ln. And we just did this one, where I have ln x plus 1 is equal to this. So I have ln x plus 1 is equal to, notice this summation is starting from what? At 0. Summation n equal to 0, infinity, minus 1 to the power n x to the power n plus 1 over n plus 1. Yeah, over n plus 1. I don't have n plus 1. Let me note some of the things here. I have 0 here. Here I have 1. I have n plus 1. I have n plus 1. I have n. And this is power. I can't deal with it easily. Minus 1 to the power something. Okay. So I want this series where I have this is n. So I will do this trick. Let k equal n plus 1. So n is k minus 1. So plug everything in terms of k. That will be summation. K or n, these are just names. So k minus 1 equal to 0. And I have, it means k equal 1 to infinity. Minus 1 of k minus 1. Okay. X to the power k over k. Now it's almost the same, except this one. Please note, minus 1 to the power n plus 1 is minus 1 to the power n minus 1 times minus 1 square. Minus 1 square is what? Is 1. So this is minus 1 to the power n minus 1. So that can be written, k or n is the same idea. K equal 1 to infinity minus 1 to the power n plus 1, or k, since I'm using k, x to the power k over k. As I said, if you put k, if I put n, these are just dummy variables. So if you look at this one and that one, they are the same. At x equal 1 over 3. So these things equal ln, yeah, so this summation minus 1 to the power n plus 1, 1 over 3 to the power n over n, which is this exactly, with k equal 1 over 3 should equal to this. That should equal ln 1 over 3 plus 1, which is ln 4 over 3. And that will be my answer. Then you need the calculator. Yeah. Okay. What is this? Now he wants to find the power series. Yeah, this is very easy. 1 over x plus 2, or I can write it 1 over 2 plus x. Actually, I did it before. I can take 2 common factor. The remaining is what? 1 plus x over 2, which is now half over 1 minus x over 2. So this series will be what? This is just a number for this one, minus x over 2 all to the power n. So I have what? Half minus 1 to the power n, x to the power n over 2 to the power n. So it's summation minus 1 to the power n, x to the power n over 2 to the power n plus 1. What's the interval? I need this less than 1. So I have to divide of x less than 2 with the minus will not make an effect. So x between minus 2 and 2. I did not do any derivative. Derivative will not change it, just integral. X cubed over x plus 2. Yeah, I know x plus 2 is this one. This is 1 over x plus 2. So that will be, I can say this is x cubed times 1 over x plus 2. And I know the series of this one. So it will be x cubed times the series of x for x plus 2. This will be the series 1 over x plus 2, which summation minus 1 to the power n over 2 to the power n plus 1 x to the power n. Multiply by x cubed, that kind of can take it inside because it's not related to n. X to the power n plus 3 over 2 to the power n plus 1. That will be the answer. The interval will be the same. Since I did not do any integration, derivative will make it plus. Okay. 1 over 1 plus x to the power 7. I want the integral of this. So let me do what this is first. This is what? 1 over 1 minus x to the power 7. So this will be this summation. N equals 0 to infinity minus x to the power 7 all to the power n. So it's minus 1 to the power n, x to the power 7n. Now I need the integral of this. So that will be the integral of this series. I need the series here, sorry. So this integral is this series minus 1 to the power n, x to the power 7n dx. Do the integral. You have what? Summation. I can interchange the integral with the sum. So I have minus 1 to the power n, x to the power 7n plus 1 over 7n plus 1. Yeah, plus c. Okay. The interval minus x to the power 7 less than 1, which means absolute value of x less than 1. Yeah, so x between minus 1 and 1. Okay. Now, consider f of x this, which is a noise summation. Just to understand now, f prime will be what? If you have f is 1 minus x to the power minus 1, what will be f prime? That will be minus 1 minus x to the power minus 2. Derivative of this minus, so that is back is plus. So this is 1 over 1 minus x squared. And that will be the summation n x to the power n minus 1. N should start at 0, but since 0 will make nothing, so that will start at 1. Then check f double prime. That will be what? Minus 2, 1 minus x to the power minus 3. Derivative of this plus, so this is comes plus. So f double prime, which is 2 over 1 minus x cubed, that will be the summation. N equal, I have n minus 1 x to the power n minus 2. Starting from where? 2, because 1 and 0 are gone. The interval should be the same. Yeah. Now we have to identify which function is this. If you remember, we did it before. Look, how to think about it. Yeah, I have something over 2n plus 1. So it means I did some kind of integration. And not for n, for x squared. So that means I'm doing the integral of 1 plus x squared. Yeah. I hope it comes easily to your mind. Yeah, because this, if you remember, this is integral 1 over 1 minus x squared. Minus x squared, sorry. And you need plus minus, huh? Plus, minus, plus, I need minus 1 to the power n. So this is, yeah, and this one is what? Integral of this summation. Minus 1 to the power n x to the power 2n, the x. And that, give me this series. And this one is what? This one is tan inverse. If you remember well, that will be tan inverse x. So that f of x is tan inverse x. You need plus c, but c will be 0. At 0, that will be 0 equals c, 0 plus c. Okay. So this is the function. I don't know if it is clear, Charlotte. Let me do more probably, try to finish this section. Now this is all the exams question. Hope they're not that difficult. Okay. F of x. So that x to the power 4 times this, which is x to the power 4. What is this series? This series n equals 0 to infinity, x squared all to the power n. So that will be x to the power 4, x to the power 2n. If I took it inside, x to the power 2n plus 4. Which is this. Yeah. Now we have to rewrite this. If x is x cubed, زائد 1 over 2x plus 1. I need 1 minus x. Okay. So this is x cubed. I'll take 2 common factor. I have x plus half. No. Yeah, we need to be sure. I need 1 minus x, huh? What I have in my mind, 1 over 1 minus x is this, huh? So I need 1 minus. So this I can write it 1 minus 2x. That I think will do it. X cubed times summation equals 0 to infinity. Minus 2x to the power n. So that will be x cubed minus 1 to the power n, 2 to the power n, x to the power n. X cubed, I can take it inside. So I'm getting this. X to the power n plus 3. And that will be my answer. This one, yeah, I need to be careful here. This is x cubed over x plus 3, over 3 plus x. Don't forget, I need 1 minus x. Okay, so I don't need 3, I want 1. So now I need to take 3 as a common factor. The remaining is 1 plus x over 3. So that will be x cubed times. That will be x cubed over 3. Yeah, 3, that will not make any effect. Over 3, 1 over 1, 1 over 1 minus x over 3. Okay. So that will be x cubed over 3. Then have the summation and equal 0 to infinity of what? Minus x over 3 all to the power n. So that will be x cubed over 3. Let me rearrange the sum. Minus 1 to the power n. X to the power n over 3 to the power n. That give me what? Summation. And equal 0 to infinity. Minus 1 to the power n. X to the power n plus 3 over 3 to the power n plus 1. Yeah. Yeah. So this will be my answer. The power series representation of this one. Yeah. You have x over 2x squared plus 1. That is what? X times 1 over 1 minus 2x squared. So that will be x times, what is the series here? N equals 0 to infinity minus 2x squared to the power n. So that will be x times. Let me arrange the series. He wrote it minus 2 to the power n or minus 1 to the power n times 2. It's okay. X to the power 2n. Minus 2 to the power n. X to the power 2n plus 1. What is this? Now he gave me n x to the power n. What is this? I have n. So I need a derivative. I don't need the integration. Because integration, the n come in the denominator. Yeah. So that is what. Just I want to remind you about these ones. Okay, look at this one. Look at this one. Multiply it by x, you get the answer. You get our answer. You notice there, we say the f of x 1 over 1 minus x. Then f prime, which is 1 over 1 minus x squared. That will be summation n equal 1 n x to the power n minus 1. Look at this one. This is n x to the power n. So I need to multiply by x. So I have x over 1 minus x squared will be this summation. N x to the power n, which is this answer. Okay. Yeah, almost there. I think the idea is very clear. N times 2 to the power n, x to the power n. Yeah, I need n times. But this is a half 2x. So actually it's summation n equal 1 to infinity n to x to the power n. Okay. So I need to think not about this. I need to think about 1 over 1 minus 2x. Yeah, since that is summation n equals 0 to infinity of 2x to the power n, which is this one. For sure, I need a derivative because I have n here. Huh? So now differentiate this, which is now be careful with the 2. 1 minus 2x to the power minus 1. What will be f prime? F prime will be 1 minus 2x to the power minus 2. There is a minus times minus 2. So this will be 2 over 1 minus 2x all squared. And that will be what? Summation n equals 0 to infinity n 2x to the power n minus 1. Did I reach this? No. I need an x here, because this is n, and this is n minus 1. Yeah. Be careful. Be careful. Be careful. This is 2 to the power n, x to the power n. So this is derivative 2 to the power n, x to the power n minus 1. 2 to the power n, just a number. X to the power n is n, x to the power n minus 1. It's not 2x all to the power n minus 1. Yeah. Yeah, the derivative is only coming with the x. Huh? This is just a number going away. So now I need to get this one. Let me do it again. Yeah, to make it clear. Avoid any mistake. This is similar to this. Yes? Now I start with what? Very clear. I start with this 1 over 1 minus 2x, which is summation n equals 0 to infinity 2x to the power n, which is what? 2 to the power n, x to the power n. 2 to the power n, x to the power n. It's a little bit tricky. Okay. Now I differentiate this. I did the derivative. That means what? 2 over 1 minus 2x all square. And that is equal what? Now the summation, let me leave this. I have 2 to the power n. 2 to the power n, just a number. The derivative comes with this one. I have n, x to the power n minus 1. Yeah, I make it starting from 1, because at 0, I'm getting 0. Okay. Take another color. Now multiply by how to get this one. I have n, good, 2 to the power n. Okay. This is I need to multiply by x. So that implies 2x over this is equal what I am looking for. N 2 to the power n, x to the power n. So this is my answer. Yeah, it's a tricky, huh? It's not 2x, and I'm not doing the derivative for 2x. Okay. 2 to the power n is just a number. Take it away. Yeah. These are the last two. I think this is easy one. We have 1 over 1 minus c to the power 4. That will be summation n equal 0 to infinity t to the power 4 all to the power n, which is t to the power 4. What they want? They want 2t over this. First, 2t, just multiply by 2t. That will be summation n equal, that will be, yeah, let me do it in steps. 2t times this summation n equal 0 to infinity t to the power 4n. And that will be summation n equal 0 to infinity 2 t to the power 4n plus 1. Okay, now we need to find the integral of this. 2t over 1 minus t to the power 4 dt, which I need to find the integral of this series, where I can interchange the series with the sum. So you have what? 2, take it away. This one, t to the power, add 1 and divide by that. For n plus 2, don't forget the summation, over for n plus 2. Here I can take 2 common factor, where I have 2n plus 1. So that 2 cancel with 2, I have summation t to the power 4n plus 2 over 2n plus 1. That will be my answer. Don't forget plus c, huh? When I did this, I have plus c for the integration. Yeah, this is the last one. I have f of x is 1 over 2 minus 6. What he wants? He wants the power series for f double prime. So let me find f and find the first derivative and second derivative. Okay. This one is what? I need 1. 1. I'll take 2 common factor. I have 1 minus x over 2. Okay. So I have half over 1 minus x over 2. So that will be half summation and equals 0 to infinity x over 2 all to the power n. So it will be half. This is f of x. Huh? Until now, I'm doing f of x. So that I can make it as one series x to the power n over 2 to the power n plus 1. Okay. Now find f prime. F prime will be what? Summation. I have n x to the power n minus 1 over 2 to the power n plus 1. So the series is starting from where? From 1. Because at 0, I'm getting 0. F double prime, which is my answer, that will be, this is 2n plus 1, just a number. This is n minus 1 to the power n minus 2, starting from 2, because 0 and 1 are gone. So I have this one. That will be my answer. Yeah, I think that's all for this section 9.9. Hopefully it's clear. It's very simple idea. So let me stop the recording. Thank you. Then I will go to 9.7 and connect it with 9.10.